Hello, I have created a timer and stopwatch with the microcontroller ADMEGA328P located on the Arduino Grove board. I programmed the microcontroller using MPLABx and a snap programmer. To use this, I had to sever a wire on the Grove board. This project uses components on the Grove board such as its button that is used to operate each mode, and a potentiometer to set the starting timer value. I have also included a breadboard which I have connected with these I/O pins. On the breadboard, I have a single-digit display to showcase the mode and a two-digit 7-segment display to display the countdown or count up. I have also included another button that will be used to toggle between the two modes. To save pins on the microcontroller, I added a NAND logic gate to control the one-digit 7-segment display. Here's the schematic for the NAND gate and how I connected it to the 7-segment display. This is where I connected the I/O pins on the breadboard. Here's the final hardware product. To begin, we can change the mode with this button on the breadboard. One is for the timer and two is for the stopwatch. To select the mode, we will use this button on the Grove board. Once we select the timer, we can then select the timer start value anywhere from 0 to 99 using the potentiometer. Here, we will set it to 3. It will now count down till 0 and then end the mode and switch to the next mode. If we wanted to stop the timer early, we can press this button. And to resume, we press it again. We can switch the mode before it finishes when it's paused. For the stopwatch, once we press this button, it will count up until 99 from 0. Just like the timer, if we press this button again, it pauses, where we can resume or switch the mode. The software component of this project uses the IDE known as MPLABx. The program is written in C and assembler code. Here is a flowchart for my code. I use an inline assembler to increment and decrement a counter that is used to change the digits on the two-digit 7-segment display. For the timer, I copy the value of the counter set by the user to register 20. I then decrement register 20 and copy the value back to the counter variable every second. In stopwatch, I copy the value of the counter, which I set to 0, to register 20, and then increment register 20 and copy the value back to the counter variable every second. The assembly language is a low-level language that allows us to communicate with the microcontroller more intensely. By using the inline assembler, I can directly access a register and directly control what happens to the value and memory placement. I did this to learn more and practice interactions between C and assembler code. However, when mixing C and assembly, the program may not notice the changes in assembly and optimize it out. This is where the volatile keyword comes into play. This keyword prevents the compiler from skipping over any code that it believes is not necessary. Another great use for assembly language is to take a closer look at the program when debugging. MPLABx has a disassembly view where we can look at how the compiler translates C to assembler. I use this feature many times throughout my tests. This project required a lot of user input. I found this to be tricky because the program would run too fast for it to clearly identify user input. This is why I created the delay method. In this method, I used the ADMEGA328P's very own timer, timer 0. This is an 8-bit timer that will count up from 0 to a set value with the speed of the microcontroller's clock. Every time it reaches this value, the clock will reset. This process will happen as many times as needed when the method is called. This will provide a buffer to read inputs more effectively. My device has two modes that can be used by anyone for anything, to set a countdown timer and time how long it takes to just do about anything. My project uses the hardware and software material covered in class and expands on it. Completing this project has helped me understand how microcontrollers work on the ground level. I am excited to learn and work more with microcontrollers in the near future. Thank you so much for watching. I hope you enjoyed and learned something. Now go and make your own project using the ADMEGA 328P.